Hello friends, welcome back. Let's look at this interesting example related to complex numbers. We have been given that alpha beta are two different complex numbers with modulus of one of the complex number is equal to 1. We have to find out what is the modulus of beta minus alpha by 1 minus conjugate of alpha into beta. So we have to find out this value. We have been given that modulus of beta equal to 1. So what is the approach to solve this problem? We will be using one particular property to solve this problem. So let's go through that property and try to understand now what is that property. That property is you take a complex number and multiply that with its conjugate, that is equal to square of the modulus of the complex number. Let us see this, how this works out. Let us say z equal to x plus iy. Then what will be the conjugate of complex number? That will be x minus iy. And what is modulus of z? Nothing but square root of x square plus y square, and you square it on both and square it. Then you will see here on the left hand side a plus ib, a plus b into a minus b. Can I say a square minus b square? X square minus I square y square equal to x square plus y square, because square root and square cancel out. Now we know that I square equal to minus 1, so x square plus y square is equal to x square plus y square. So this is a particular property which we are going to leverage to solve this problem. This is the property which we are going to leverage. So let's go ahead and leverage that property and try to solve the problem. So let's go ahead and leverage this property what we have just learned. First we will leverage it here. We know modulus of b is equal to 1. So now if I want to leverage this particular property, I need modulus of b whole square, and I know 1 square is 1 square, 1 only. So can I say modulus of b whole square is equal to, or it's actually beta, we are saying alpha beta, so pardon me for that, it's beta. Modulus of beta equal to 1, modulus of beta whole square is also equal to 1, but that's nothing but equal to beta into conjugate of beta, that is also equal to 1. So this property we are going to use in the problem afterwards. Now again we have been given modulus of a complex number we have to find out, but we will square it up so that we can write it as product of the complex number and its conjugate. So what we will do, what we have to find out, we will take it and we will square it. So we'll write it as beta minus alpha divided by 1 minus conjugate of alpha into beta. We have to find out this, we will square it, and we know that if I square it, that's nothing but the complex number and product of complex number and its conjugate. So can I say that it's nothing but equal to, first let's separate them. We will say beta minus alpha modulus whole square divided by 1 minus conjugate of alpha into beta whole square. We can do that because we know that modulus of z1 by z2 is equal to modulus of z1 by modulus of z2. We can leverage that property. Now we will leverage the property whatever we have just learned, and we will write it as this is equal to beta minus alpha multiply with beta minus alpha conjugate whole conjugate divided by 1 minus alpha conjugate into beta into 1 minus alpha conjugate beta whole conjugate. Now our complex number itself is again combination of complex numbers. So when you want to find out conjugate, you have to go to each complex number inside and make it as a conjugate to get the conjugate of the whole complex number. So it will be like now beta minus alpha, multiply that with conjugate of whole beta minus alpha is conjugate of beta minus conjugate of alpha. That is coming from the property conjugate of z1 minus z2 is equal to conjugate of z1 minus conjugate of z2. divided by, now 1 minus alpha conjugate into beta, and here 1 minus, it will be alpha into beta conjugate, because we are saying we want the conjugate. Now let's go ahead and multiply this and see what happens. Beta into beta conjugate minus alpha into beta conjugate minus alpha conjugate into beta, alpha conjugate into beta, plus alpha into alpha conjugate, divided by, we have 1 minus alpha into beta conjugate minus alpha conjugate into beta, plus minus into minus is plus, and I have alpha alpha conjugate into beta beta conjugate. Now let me see that this beta beta conjugate here and here, they both are equal to 1. We know that they both are equal to 1. These two are equal to 1. We already proven that. So can we go ahead and replace them with 1? Then obviously we will have numerator equal to denominator, and the answer will be equal to 1. Let's go ahead and do that. So the final step will be 1 minus alpha into beta conjugate minus alpha conjugate into beta plus alpha into alpha conjugate, divided by 1 minus again alpha into beta conjugate minus alpha conjugate into beta plus alpha into alpha conjugate. So both numerator and denominator are equal to 1. So the answer is 1. This is one method of solving it, where you are applying a property. If you think that you are not comfortable with this property, what is that? Multiplying a number with its conjugate equal to square of the complex number. We can go to the traditional way of taking alpha as one complex number x1 plus iy1 and beta equal to another complex number x2 plus iy2. Then we put the conditions and we can try to solve them. Let me show you how to do that now. So in the second approach, what we will do, we will take alpha beta as some different complex numbers. So I say alpha equal to x1 plus iy1. This is another way of solving it. Can I say beta equal to x2 plus iy2 then? And we have been given modulus of b equal to 1. So can I say square root of x2 square plus y2 square equal to 1, or x2 square plus y2 square is equal to 1, because we have been given that modulus of b is equal to 1. Okay, let's go ahead now. What is beta minus alpha? Let's do them separate now. We will separate numerator and denominator. What is beta? x2 plus iy2 minus of alpha, that is x1 plus iy1. We want modulus of this, and we want to divide that with 1 minus alpha conjugate, that is x1 minus iy1, because you know whenever it's a conjugate you have to make plus to minus. And what is beta? Nothing but beta is x2 plus iy2. So we want modulus of numerator and denominator. So let's go to the next step now. We'll try to separate them and write it as x2 minus x1. Can I write it as x2 minus x1 plus I into, can I say iy2 minus iy1? Can I say y2 minus y1? I into y2 minus y1. This whole thing I need the modulus, divided by, why we are writing this? Because if I write down a plus ib, then I know modulus is square root of a square plus b square. So that's the logic we are following now. Now what will be the next step for this? The next step will be, we have to simplify the denominator. So it will be 1 minus, let me write it down, x1 x2, then afterwards minus x1 into plus I y2. So can I say minus I x1 y2? After that I y1 into x2. Can I say plus I x2 y1? Then afterwards minus into minus is plus, I into I is I square y1 y2. Can I say minus y1 y2, because I square is minus 1. So let's go ahead and write it down and try to find out the modulus of numerator and denominator, and let's prove that it's equal to 1. Remember, we have a condition given to us that x2 square plus y2 square is equal to 1. This is a condition which will come to us handy when we solve the problem. So let's go to the next step. So the next step will be, we'll take the numerator and we'll write it down for one more time. We will say x2 minus x1 plus, that is my a, and I into y2 minus y1, that's my b. This is a plus ib. I need a modulus of that. Let's separate and find out a and b values here also. I have 1 minus x1 x2 minus y1 y2, that is my a part, plus I into, what is the b part? Let us see. I into, we have, okay, let me just check this. It should be x2 y1, right? We have x1 y2. This is x2 y1. That's a mistake on my part. So we have I into x2 y1 minus x1 y2. If this is x1 y2, this should be x2 y1. We are okay with that. Okay, fine. Now this is in the form of a1 plus ib1. Let's write down. This is a1 plus ib1 divided by a2 plus I into b2. What you need is square root of a1 square plus b1 square divided by square root of a2 square plus b2 square. That's what we want to find out. So let's go to the next step. So we know that's nothing but equal to x2 minus x1 whole square plus y2 minus y1 whole square, and I have square root for that, and I divide that with again square root. What I am going to write now is, this is in the form of a plus b plus c whole square. What is the formula for a plus b plus c whole square? A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So can we apply that particular formula here? What we will be getting is 1 square is 1 plus x1 square x2 square plus y1 square y2 square, then a square b square c square, 2ab, that is minus 2 x1 x2 minus 2 y1 y2, then afterwards plus 2 x1 x2 y1 y2, then this is the square of this. We have done that. Oh, we have just applied the square directly. Okay, I'll write down, this is nothing but 1 minus x1 x2 minus y1 y2 whole square plus x2 y1 minus x1 y2 whole square. Can I write down that? That is x2 square y1 square plus x1 square y2 square minus 2x1 x2 y1 y2. So let us see what we can cancel here. One step, if you think I have missed it, I'll write down here. 1 minute, just give me a minute. I'll change this so that you are comfortable. Let me just change it. I'll just erase this part inside and I'll write it. One more step I'll write down here. So this is nothing but, now this is x2 square plus x1 square, because x2 minus x1 whole square, minus 2x1 x2 plus y2 square plus y1 square minus 2y1 y2. That's one step is missing there. That step I'll write down now next to this. So that this is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square divided by, this is the step which is missing, I am writing down, that is square root of 1 minus x1 x2 minus y1 y2 whole square plus x2 y1 minus x1 y2 whole square. This step I have missed. I have just directly went to the formula. A plus ib is square root of a1 square plus b1 square, and we have expanded it. Now let us see what we can cancel here. I see this and this I can cancel. Then also we know x2 square plus y2 square is equal to 1. So can I go ahead to the next step and write it as, in the numerator part we have 1 plus x1 square plus y1 square minus 2x1 x2 minus 2 y1 y2. Let us see, can we get the denominator is same 1 is okay, and minus 2x1 x2 is okay, this is taken care. Minus 2 y1 y2 is also okay. What else we need? We need x1 square. Can we take common x1 square and write it as x1 square into x2 square plus y2 square? Because we know x2 square plus y2 square is 1, then this becomes equal to x1 square. Similarly, one more we are left out, that is y1 square. Can I take y1 square common in denominator here and here? Where is my y1 square? Here, if I take these two common, I can see that y1 square into x2 square plus y2 square. So if we simplify that, we can use x2 square plus y2 square equal to 1 property. That's our last step. Our next step, by taking x2 square plus y2 square equal to 1, will yield us that the numerator and denominator both are equal, and that is 1 plus x1 square plus y1 square minus 2x1 x2 minus 2y1 y2 whole thing divided by, again, 1 plus x1 square plus y1 square minus 2x1 x2 minus 2y1 y2. This is equal to 1. So this is another way of proving. You can see that it's a little bit more lengthier. If we do it by properties, it will be little bit easier. If you are not getting the properties, you are not understanding them, then this method is always there. Only the thing, remember, x2 square plus y2 square equal to 1. So that's one interesting example which I thought of sharing with you. When it has been given that alpha beta are two different complex numbers with modulus of beta equal to 1, we have to find out the value of modulus of beta minus alpha divided by 1 minus conjugate of alpha into beta. So the approach we have taken is, we have said that if you take a complex number and multiply that with its conjugate, it's nothing but equal to square of the modulus of the complex number. So z into conjugate of z into z dash above is nothing but equal to modulus of z whole square. So that's a one property which we have leveraged and tried to solve this problem. Thanks for your time and support. I'll catch you once again with another interesting example. Till then, bye for now.